All right, you guys, in our last video, we learned about the 5 common shapes for VSEPR theory. And now what we're going to do is we're just going to do some examples to show you how VSEPR theory works with certain molecules. So if you can just follow along as we go through some examples. EX here means example. Let's say I wanted to know what the shape of this molecule was. And let's say I did PF3, okay? First of all, it is impossible for me to just look at my formula and determine what the shape is. You have to start by drawing the structure, okay? And structure is going to help tell you what the shape is. So you're going to follow the rules for drawing a Lewis dot diagram or Lewis dot structure, and you would get a structure for PF3 that looks like this. Now, if you're not sure how to draw Lewis diagrams, or what I call dot structures, you're going to want to go back and find the videos on drawing Lewis dot structures. Okay, once I have the correct structure drawn, which I have right here, I am going to use what I know about this molecule. Now, first things first, when we're talking about Lewis diagrams, we're talking about VSEPR theory, we do not care about the atoms on the outside of a molecule. We are only concerned with the central atom, its bonds, and its lone pairs. And that's going to help you do this much more easily. So we take a look at the P in the middle. How many bonding sites does it have? Well, it has 1, 2, 3. So it has 3, what I call bonds, okay, or bonding sites. Then we have to look at whether or not that central atom has a lone pair. It does. So it has 3 bonds with a lone pair. Now, initially, you're going to need to look back at your notes to figure out the shape, but eventually, you're just going to know these. So I'm going to look for this part of my VSEPR notes. I'm looking for something with 3 bonds and lone pairs on the central atom. And here's where I find it. 3 bonds with lone pairs. That lone pair pushes down those bonds, and my shape would be trigonal pyramidal. So I would write that down as my shape. All right, let's do a couple more. So let's say I have as my molecule NO2 minus. And again, that's a polyatomic ion. You should know how to draw that structure already. And again, you cannot determine what the shape is without taking the extra step of actually drawing the structure. So here's what the shape of NO2 minus is. And you're going to notice that this is what's called a resonance structure, which means I could draw the shape like this, or I'm sorry, the dot structure like this, or like this. Okay, so that's resonance. But let's take a look to see what we can figure out for the shape. So once again, when I'm determining the shape, I ignore the atoms on the outside. And by the way, you don't have to check both shapes. You can just check one of a resonance structure. So let's count. How many bonding sites do I have? Be careful. I know that there's 3 lines here, but each of them counts as a bond. So there are just 2 bonds. And now I check the central atom for lone pairs. And there's a lone pair on the central atom. Okay, so let's go to our notes. 2 bonds with a lone pair on the central atom. And I look at my notes. Which shape has 2 bonds with a lone pair? It's this one, bent. So I would write down as my shape for this one, bent. All right, next up. This is an example of one that we actually didn't have in our notes, so I thought it would be helpful for us to have here. If I have a compound like HF, and I draw the structure for it, you all are going to find that this is what the structure looks like. Now, in this case, we really don't have a central atom. And that's going to occur whenever I only have 1 bond, whether it's a single bond or a double bond, or even a triple bond. In all three of these cases, do you all notice there isn't a central atom, and I simply have one bonding site between the two atoms? So let's go to our notes. Again, this is one we did not have an example of, but we have it right here. Anytime I only have one bond, the shape is going to be linear. So I would write down for any of these three that the shape is linear. All right, just a couple more. So I'm going to give another example here, and we're going to see if we can figure out what shape this one has. Cl3I. And if you were to go ahead and draw this structure, it's going to be a C in the middle with 3 Cl's and an I. And this would be the complete and correct Lewis structure for this, or dot structure for this. And again, let's figure out what shape it has. So I first draw the dot structure, and then again, I only pay attention to the central atom. So this is all I look at. Now notice I never erase the bonds coming from the central atom. Those are super important. How many bonds do I have? I have 4 bonds coming from the central atom, and there aren't lone pairs. So we look at our notes. I only have one bonding shape that has 4 bonds, and that's going to be tetrahedral. So I would write down for my answer here, tetrahedral. All right, let's do a couple more. So the next one I'm going to try is going to be H2S. So I'm going to go ahead and draw this structure for H2S. S would be in the middle, H, dots, dots. Okay, so I ignore the outside atoms when I'm figuring out shape, and I simply pay attention to what's next to my central atom. Do you notice I have 2 bonds here? And then I just check for lone pairs. Do I have lone pairs? I do, and it doesn't matter if it's 1 or 2 lone pairs. They're both going to do the same thing. So now let's look at our notes. 2 bonds with lone pairs right here, and the shape is going to be bent. All right, I am going to maybe do one more for you guys. This is a shape that you would have to be given, because this is in violation of the octet rule. When you see this structure, this is one that we would never expect you to draw on your own. Do you notice that my B in the middle does not have an octet? There are some exceptions to the octet rule, and boron is one, that sometimes only has 6 electrons around it. Again, you would never be asked to draw this structure, but if I gave you this structure, you should be able to tell me its VSEPR shape. So again, we ignore all of the exterior atoms, and we simply look at the central atom. How many bonds do I have? 3. I have 3 bonds, and notice that empty spot, no lone pairs on that central atom. So we go to our notes. 3 bonds with no lone pair is going to be, sorry about that, this shape right here, it's trigonal planar. All right, and that is a bunch of examples of how we determine shape based on looking at the dot structure. Good luck working on your packet with all of the problems that are similar to this.